So how in the world do you put a price on the future? It sounds kind of impossible, right? But it's exactly what Wall Street does every single day with things called financial options. Today, we're going to pull back the curtain on one of the most foundational tools they use, the one-period binomial model. And trust me, it's way simpler than it sounds, and it's probably going to change how you think about financial risk forever.
You know, this quote from Emmanuel Derman just perfectly frames what we're doing here. We're not trying to become physicists or memorize some crazy complex formula. Nope. We're just going to patiently take apart a core mechanism, a really elegant piece of financial logic. And once you get it, I mean really get it, your whole perspective on risk and value is going to shift. It's pretty cool.
Okay, so where do we even begin? Well, we start by building a simplified world. Think of it like a financial laboratory. You know, the real world is messy, it's chaotic, there's a million things happening at once. The absolute genius of this model is that it ignores all of that noise. It forces us to focus on just a handful of really critical variables.
And that's really all a financial model is when you get down to it. It's not a crystal ball, it's not magic, it's just a tool, a very specific tool. We feed it some inputs, it follows a set of rules, and then it spits out a logical output. Our model today is going to do exactly that. So welcome to our simplified world. It's pretty bare bones. We have today, the present, and we have tomorrow, the future. That's it. Today, a stock has a price, we'll just call it S, and tomorrow, well, only two things can possibly happen. The price either goes up to SU or it goes down to SD. No other possibilities. And naturally, the value of our call option, that's the right to buy the stock at a set price, well, its value is going to change right along with it. Now, this little world of ours has one golden rule, and it's summed up in this little formula. This isn't just some random math, it's a super important guardrail. All it's really saying is that the risk-free return, what you could get from a super safe government bond, has to be somewhere between the stock's potential up return and its down return. Why? Well, if it wasn't, you could create a money-making machine. You could just borrow money for cheap and get a guaranteed high return. And in finance, that's called arbitrage, a free lunch. This rule makes sure there are no free lunches.
All right, now here's where things get really, really clever. So our world has two possible futures, right? Up or down. That means there's risk. But what if we could build a portfolio, a combination of assets that ends up being worth the exact same amount tomorrow, no matter what happens? What if we could literally engineer the risk right out of the equation? And this is how we do it. We use something called a hedge portfolio. You can think of it like a carefully balanced recipe. On one side of the scale, we buy a very specific number of shares of stock. We'll call that number H. And on the other side, we sell one call option. By selling the option, we're taking on the obligation to sell the stock if the price goes up. This specific combo, buying the stock and selling the option, that's the secret sauce to creating that perfect balance.
The logic here is just so elegant. First, we figure out what our portfolio's worth if the stock goes up. Then we do the same for if the stock goes down. And here's the crucial step, the aha moment. We just decide to force those two outcomes to be equal. We literally say, I don't care if it goes up or down, I want this portfolio to be worth the exact same amount either way. The only thing we don't know is H, that number of shares. So we solve for H, and that gives us the magic ratio that makes our portfolio completely 100% risk-free.
So we've done it. We've engineered a portfolio that has zero risk. And now that we've done that, a fundamental law of finance just kicks right in. This is the bridge that's going to connect that certain future value all the way back to a fair price for our option today.
And this right here is that law. It's a big one. If a portfolio has absolutely positively no risk, its future value is a sure thing, then it must earn the risk-free rate of return. It can't earn more, because if it did, everyone would pile in. And it can't earn less. It has to earn exactly the same rate you'd get from something super safe like a government bond. It just has to.
And that brings us to this. The final step, the value of our risk-free portfolio today has to be equal to its guaranteed future value, just discounted back by that risk-free rate. It's a direct link. And if you look at this equation, the only thing we don't know is C, the value of the call option today. Everything else, we know it. So now we just solve for C.
Okay, that was a lot of theory. Enough theory. Let's make this real. Let's plug in some actual numbers and see this thing in action. We're going to walk through the whole process and calculate an actual option price right here, right now. All right, here's our setup. We've got a stock that's currently trading at $100. The option we're looking at also has an exercise price of 100. In our simple world, the stock can either jump up by 25% to 125, or it can fall 20% to $80. And that risk-free rate we talked about, it's 7%. Okay, let's get to work. First things first, what's our option actually going to be worth tomorrow in these two scenarios? Well, if the stock shoots up to 125, our option to buy at 100 is in the money. It's worth 25 bucks. Easy. But if the stock falls to 80, well, an option to buy at 100 is worthless. So its value is 0. Simple enough, right? Now for the magic number. After we run the calculation from our hedge recipe, this is what we get, 0.556. This is our H. This is our hedge ratio. What this actually means is that to build that perfect risk-free portfolio, we need to buy exactly 0.556 shares of stock for every one call option we sell. It's that precise ratio that cancels out all the risk. And now we have all the pieces of the puzzle. We take our hedge ratio, the 0.556, we take the potential up and down values for the stock and the option, and we take our 7% risk-free rate, and we plug them all into our final pricing equation. We do a little bit of arithmetic, and boom, the model spits out a single, precise number, $14.39. That, according to our model, is the fair value of our call option today. We've just priced the future. Okay. Just take a second and think about what we just did. We built an entire world. We created a totally risk-free portfolio, and we calculated a super precise price. But there's one piece of information that seems like it should be incredibly important that we never ever mentioned. What was it? Yeah, we never once asked about the probability. What are the chances the stock goes up versus down? Is it 50-50? Maybe 70-30? It feels like that should be the most important question, right? But does it actually matter for the price? And this right here is the most profound, most mind-bending insight of the entire model. The real-world probabilities are completely, totally irrelevant to the price. Why? Because we created a portfolio that is worth the exact same in either future state. It literally doesn't matter how likely each state is. The price isn't determined by guessing the future. It's determined by the cold, hard logic of preventing a risk-free profit. And that's the really powerful idea I want to leave you with today. How is it possible that a model built in this tiny, artificial world, a world that deliberately ignores our best guesses about the future, how can it produce a price that is so fundamental to all of modern finance? It's a fascinating question to chew on. Thanks so much for joining me.